All right, so hold on. Don't look at all my chaos yet. Let's look at the title first and pop that down. So 6.1, add and subtract polynomials. We can add the date too if that helps some of us. So I'll add the date up top. Okay, so there's a few different kinds of polynomials, you guys. So let's look at the first one. You're going to see polynomial, right? Poly means many. That means many terms. So that would be an example of a polynomial. So 2c to the third plus 10c to the second minus c minus 5. So you have many of them, right? There's one there, there's one there, there's one, and there's one. Those are the different terms. So that's polynomial. Let's look at the next one. Monomial. That means one term, right? Because mono is one. And so an example of that would just be 9. Could be a 2, could be a 3, could be a 10c squared, whatever. But there's just one term there. So monomial. Sorry guys, there it goes. Okay. So let's see, binomial. Bi, remember, 2, right? So 2 terms. Binomial means 2 terms, and this is an example of 2 terms. Your 15p squared is one term, and then your 9 is another term.
So bi is 2 like a bike.
Let's look at, I believe that's our last one. Yes, so trinomial. Tri means 3, right? So trinomial is 3 terms. Your example of that would be your 46x to the 5th power. That is one term. Then you have your x squared y cubed. That's a term. And then y squared is another term. Record. Okay. So you're going to hear the words like terms a lot. Okay. So like terms are terms whose variables are the same. And our variable in this example would be the x's, right? So they all have an x attached to it, which is the variable that makes them all like terms. So 7x and just an x and a negative 2x. Those are all like terms. All right, so let's move on. Yeah, here's the little... So exponents, I know Miss Myers touched on that, which was good because I didn't kind of have it written down like that, so that was good. So exponents... That's these guys, right? So x squared, 7 cubed, or 7 to the 3rd power. I'm not sure. Does it matter how we say it, though, Miss Myers? Okay. Because I say it different sometimes. It just whatever pops out. So, and then we have negative 4 squared. So all those are like terms because they all have that exponent, right? They all have an exponent. So they're like terms. But if one of these, if this was just x, then they wouldn't be like terms. And that's what she was telling you. All right, so let's look at an example. Okay. So if we have 7b squared plus 6b squared, remember these guys are like terms, and when we have like terms, they stay the same when we go to solve it, okay, or to simplify it. Okay, so write that down first, and then we'll go ahead and work that one out. I wrote this here. At least one time, probably write it down. I wrote it down for every problem just to remind you, but at least write like terms means stay the same one time like that in your notes with this one. Okay. So, when we have something like this, we're just going to take, and also I didn't underline it, but the 7 and the 6, those are like terms, right, guys? So they're just numbers, right? They're like terms. So 7 plus 6, but you're going to, actually they wouldn't be because that wouldn't follow the rule because they won't stay the same. So we'll just look at the ones with the variables. So 7 plus 6, that should give us what, 13? Okay. And then Like I said, the b squareds, those are like terms, so they stay the same. We don't do anything to them. We just write them after we add the 7 and the 6. So that one would just be 13b squared. Does that one make sense? I know that one's an easier one. We are going to get more complicated, so just warning you. On that one, that's it, Cheyenne. Yes, that's it on that one. But they're not all going to be that pretty, so just want to prepare you.
One of the things you're going to have to be careful about is that, like the b squareds are the same. Like if you had a b to the third, you couldn't add it together. And yes, for conversion, the b squared stays the same. Because it's kind of like you're saying, like if you reword that and say you have 7.
All right, let's look at this bottom one. So we have, let me move it a little bit, 2a minus 6a. And remember, those a's are like terms, so they're going to stay the same. So this one's similar, obviously, the first one we did. So go ahead and, if you think you know the answer, pop it in the chat too. So 2a minus 6a. Okay, let's see a negative 4a, all right. Okay, let's see a positive 4a. All right, so let's see. We're just doing 2 minus 6, which would give us that negative 4. Oh, sorry, that was sloppy. And then our a stays the same. So negative 4a. Let me try to write that a little neater. My hand doesn't want to write after 2 weeks, apparently. Doesn't want to do math. All right, go ahead and write that down. So we have 2a squared plus b squared minus 8a squared. And if you see your a squareds and your a squared over here, those are the like terms. Those two will stay the same. We're going to look at this one. So let's look here. Okay. So we want to do, we're going to look at our numbers in front of our variables, right? So we have a 2 plus a b, but remember when there's no number there, guys, that just means that there's a 1 there. That looks funny, sorry. So 2 plus 1 gives us 3, and then we're left with 3 minus 8, right? So that gives us a negative, wait, did I do that right? 2, 3, oh, I did it wrong over here. Sorry. Just caught my own mistake over here, sorry. So 3 minus 8, that would give us what, a 5? Or a negative 5, right? I wrote the wrong number over there. Confused myself. Okay, so we have a negative 5, right? Okay, and then we have our, oh wait, what did I do? Oh shoot, sorry. Just ignore what I did. I see what I did wrong. I did it right the first time, did it wrong this time. Ugh, my brain. Okay, sorry. Ignore what I said. We're at the point where we wrote down the problem. I'm going to get rid of that bad boy. Okay. Ugh, it's been a long 2 weeks. Okay, so since these ones are like terms, we're going to work with those two first. Okay, so that's where I got my correct number 6 there. So 2 minus 8, that gave us the negative 6. And then our a squared are like terms, so they stay the same, right? So that part's like that. Then we're left with our lonely 1b squared, but we don't need the 1. So we just write plus, we have to have that sign, right? That addition sign, plus b squared. So we can't solve it all the way, we just simplify it to that. Sorry, I confused you in the beginning, but does that make sense now? So we work with our like terms. We do our 2 minus 8, which gives us the negative 6. We put our a squared in there. And then we can't do anything with the b squared because we don't have another like term to do anything. So it stays the same. We just add it on there. So negative 6a squared plus b squared. Yeah, simplify, not solve on most of these, I think, unless you get that simple, easy one in the beginning, but yeah. Okay. Sorry, terms. So you can underline them if you'd like. Make that a little more noticeable so you don't forget about them. So 2a minus 3b minus 4a. And if you want to pop it in the chat, if you think you have the answer on that one, go ahead. Otherwise, we will still work it out together. It would be, we have to look at our 2a and our negative 4a, right? So 2 minus 4 would give us that negative 2. And then our a stays the same because that's our like term. And then we're left with that negative 3b, so we just write them on in. So it should be negative 2a minus 3b. Okay, we have a 5s squared plus a 3s plus a 1. All that in parentheses, they want you to add it to 6s squared plus 2s plus 4. And then I underlined our like terms, right? So we have 5s squared, 6s squared. Those are like terms. And then the 3s and the 2s, those are like terms. Okay. There it goes. All right. So let's look at our first set of like terms, right? We're going to look at our 5s squared and our 6s squared. Okay. So this one's pretty easy. We don't have any negative signs to deal with. So we're just doing 5 plus 6, right? And that gives us 11. And then our s squared is the like term, so that just stays s squared. That looks like a 5. That is an s. Oh my goodness. There we go. It's a little better. So we have our 11s squared first, right? So we're done. We did these. Those are done. So now let's look at our next set of like terms, and we have 3s and 2s. Again, we're just adding. We don't have to deal with any negative signs, which makes that a lot easier. So then it's going to be a 3 plus a 2, which would be a 5. We keep our s the same. That is too much. I don't ever want to use s's again. So 5s. And then we're left with our 1 plus 4, and that gives us 5. So it should be 11s squared plus 5s plus 5. Juliana, good job. In there. So write that one down. We have 7w to the third minus negative 2w squared minus 1. And we're going to minus all that from negative 7w cubed plus 2w squared plus 1. And your w cubes here are your like terms, and your w squared are your like terms. Let me know when you have that written. So let's look at this. All right. So we have a 7 minus a negative 7, right? So if it is easier for you, maybe you can't do that in your head, write it down. Okay, so it would look like that, right? 7 minus a negative 7. Those two negatives become a positive, so we just add it, right? So it should be a 14, right? Should be a 14 w cubed, because our w cubed stays the same. Okay. Then we have a negative 2 minus a 2. Right? So it would look like negative 2 minus a 2. And that should give us what, guys? I see a yep, someone put a looks like that. Negative 4, so yes, you're right there. So a negative 4 w squared, because that's our like term and it stays the same. And then we're left with negative 1 minus a 1. So negative 1 minus 1. And that gives us a negative 2, correct. So you guys should have got this guy right here. So 14w cubed minus 14w squared minus 2. Looks like a subtract 2x squared plus 2 from 5x squared minus 4x minus 4. So we're going to have to rewrite that, right? Because it wants us to subtract this from this. Okay? So that's how it would be given to you on your assignment. So if I'm going to rewrite it, it's going to look like 5x squared minus 4x minus 4. And we're subtracting. It tells us to subtract, so that's where that comes from. And then we have our 2x squared plus 2. So when you see it like this in your assignment this week, rewrite it like that, and then you can solve it. So go ahead and do that, and if you get an answer, okay. So we have a 5 minus a 2, right? 5 minus 2 would just give us a 3x squared, because we have to put our like term in there. Okay. Then we don't have a like term for this guy, do we? There's no other anything over here with just an x. So that just goes into our problem. We don't do anything with him. Okay? And then we can do negative 4 minus a 2, which would give us a negative 6. So let's see. Were you correct, Carlos? Oh, you were super close, man. You just got a couple of your signs mixed up, but that's it. Okay, so 3x squared minus 4x minus 6.